Well, Lonnie, in physics lately I've been having a really hard time. Like in chapter 12, I'm not really understanding it very well.
Yeah, I'm not really getting chapter 12 either.
Do you think maybe, like, Janetta and Brett and Sam can help us figure out?
Yeah, no, we could totally help you. Do you want to, like, do an extra problem from chapter 12 together?
Yeah.
We could show you.
That sounds really good.
Let's find one.
Well, okay.
Come over.
Okay.
Here, I'll come squish with you.
77 looks good.
Okay. Oh, okay. What's that one about? Is that the duck one?
Yeah, the duck one.
About a duck.
A swimming duck.
Okay.
Okay, so let's work on that one.
Okay, let's go.
Okay, so the problem is number 77. It says, a swimming duck paddles the water with his feet once every 1.6 seconds, producing surface waves with that period. The duck is moving at a constant speed in a pond in which the speed of surface waves is 0.32 meters per second, and crests of the waves ahead of the duck are spaced 0.12 meters apart. So the first part of the question is, A, what is the little quacker's speed? And B, how far apart are the crests behind the duck?
I like this problem.
So, Sam, I was wondering, to start the problem, if you could, like, draw a diagram, because that's how I figure it out better if there's, like, a picture.
Sure. Alright, so it says there's a swimming duck. I'll draw the duck.
Nice duck.
Thank you. And it's swimming in a pond. So we'll make some waves. Alright, so first of all, it says that the swimming duck paddles the water with its feet once every 1.6 seconds, producing surface waves with that period. So
the period is 1.6 seconds?
yeah, which is, we're going to label that as T, which is the period, equals 1.6 seconds.
Okay.
Then it says that it's moving at a constant speed, in which the speed of the surface waves is 0.32 meters per second. So we're going to label that as V, as 0.32 meters per second. Okay. Then the last information that gives is that the waves ahead of the duck are spaced 0.12 meters apart. So what that means is from this part of the wave, this part of the wave is 0.12 meters apart.
Okay, well now let's learn how to do the actual problem now that we have the diagram.
Yeah.
Okay, so part A in the book asks, what is the little quacker's speed?
Oh, so how are we gonna find that? Can we go over that?
Well, I think we would use the formula. This formula. Velocity of the water minus velocity of the duck all over the frequency.
And the frequency is what again?
The number of waves it makes per second. And so then if we rewrite this equation for velocity of the duck, we get so Janetta, do you want to write out what the different variables are?
Sure. Okay. So variables. Alright. So we know that the period, as Sam said earlier, is 1.6 seconds. And then the frequency is 1 over t, also known as 0.625 hertz. Okay, and then the wavelength is also equal to 0.12 meters. And the velocity, being attacked by a cat, the velocity is 0.32. Oops. So that got a little messed up by cat. But, yeah.
Okay, thanks Janetta. So Lonnie, next what we do is we plug in the variables into this equation.
Right, makes sense.
So we have V, which is 0.32, and then we have that to be 0.12 times
Point.
Oh, this is not minus, this is times.
Oh, okay.
Large.
Yeah, that makes more sense.
And then times f of s, which is 0.625. So then the answer, no, I think it's okay, because then we multiply that out with our calculator.
Oh, okay.
And we get 0.25. Is that what you got?
Yep, that's what I got.
Oh,
Meters per second.
cool. Well, that wasn't that hard.
So that solves the first question as to what the quacker's speed was. Does that look right to you, Sam?
That sounds about right.
Okay, I get it.
Okay.
Looks
It's
good.
great. Yeah,
It looks good.
You know what we should do? Maybe like go look at ducks swimming in the pond.
Oh, yeah, that
To
would help me.
see-
Yeah, that would help me a lot.
to
See,
visualize it?
visualize. Yeah.
A pond or maybe a bathtub?
Yeah.
Okay, same thing.
same difference.
Let's go to the bathtub. Wait, I gotta get the quacker.
Hang on. Are quackers Halloween time?
Oh. Okay, here we go. In the darkness.
Oh, okay.
Wait.
See, here's our quacker. It's vampire status.
Oh no.
Let's look at the waves it's making.
Oh, well, it doesn't really
Oh, look at
But
those
it's
waves.
still making waves.
Wait, let
I
me
wonder-
help it with its velocity.
Oh, well, I guess it doesn't really stimulate.
I guess we need a real duck.
So, part B says, how far apart are the crests behind the duck? So,
Well, isn't that just the wavelength again? Like, can't we just use that same equation that we used before?
no, Sam.
Well, we're going to use the same equation, but since we're trying to find out the crest behind the duck, we're going to add the two speeds together. So, wavelength, still use the same thing, except we use the velocity plus,
Is that what's different from one equation to
Yeah.
the other?
so in the first equation we subtracted the two speeds over the frequency of the duck. So, we already know that it goes 32 meters per second, and then we just found out the new velocity, that's 0.25 meters per second, all over the frequency, which we solved to be 625.
Huh. Oh, so that's way easier than I thought. You just plug it in. Basically.
Yeah.
Let me see if I can get it right.
So just calculate that out. You should get 0.91. Right?
That's exactly what I got.
Alright, so it's 0.91 meters. So that's how far apart the crests are, which is from here to here, behind the duck. 0.91.
Okay,
That
so I
makes
was
so
thinking
much
maybe
more
it was
sense.
that hard,
Yeah.
but it's okay.
Cool.
Okay, well, that was a lot easier than I thought.
Yeah, thanks for helping us.
Hi, I'm Lily the cat, and I've been watching this physics discussion, and I was noticing that I learned a little physics myself. In front of the duck, the wavelength is decreased, and behind the duck, the wavelength is increased. And I also noticed that the speed of the duck, which is 3.25, is 78% of the speed of the water. So the Doppler effects are large. Thank you.
That